Now let us discuss about another important function like the gamma function. This function is called a beta function and it is defined as a two variable function, beta of x comma y, where these arguments x and y are always assumed to be positive. It is defined like this: beta of x comma y is equal to 0 to 1 t power x minus 1 into 1 minus t power y minus 1 dt. So this t is a variable, and you can observe that since t is running from 0 to 1, this t is positive as well as 1 minus t is also positive. In beta of x comma y, this x and y are appearing as powers of t and 1 minus t. So t power x minus 1 and 1 minus t power y minus 1. And you can write beta function in terms of sine functions and cosine functions also. Beta of x comma y can be seen to be 2 times integral 0 to pi by 2 sine theta raised to 2x minus 1 cos theta raised to 2y minus 1 d theta. In order to observe this, you can just put t equal to sine square theta here. So what happens is, when t is equal to sine square theta, your t power x minus 1 will be sine square theta power x minus 1, which is sine raised to 2x minus 2 theta. 1 minus t power 1 y minus 1 gives you 1 minus sine square theta raised to y minus 1, that is cos square theta raised to y minus 1. So that is nothing but cos 2y minus 2 theta. Now dt, it becomes 2 times sine theta into derivative sine theta is cos theta d theta. So the integral will have a constant 2, and the limit when t is equal to 0, theta is also equal to 0 because sine theta is equal to 0. When t is equal to 1, sine theta should be 1, so theta equal to pi by 2. So that's how you get this particular form for beta of x comma y. Beta of x comma y is equal to 2 times integral 0 to pi by 2 sine theta power 2x minus 1 into cos theta power 2y minus 1 d theta. Of course, by taking t equal to 1 by 1 plus u, we can write beta of xy is equal to integral u power x minus 1 divided by 1 plus u power x plus y d. Because when t is equal to 1 by 1 plus u, your dt will become minus 1 into 1 plus u raised to minus 2. So that when you substitute it here, you can easily observe beta of xy coming as of this. It is easy to observe that beta of x comma y is equal to beta of y comma x. It is because when instead of beta of x comma y, if you put y comma x, then what happens is it will be integral 0 to 1 t power y minus 1 into 1 minus t power x minus 1 d. Now when t moves from 0 to 1, your 1 minus t will move from 1 to 0. So ultimately, when you change this x with this y, what happens is, instead of the first term moving from the first expression, the variable moves from 0 to 1, and the second expression, the variable moves from 1 to 0. You interchange this. So the first term will move from 1 to 0 and second term will move from 0 to 1. So that is the only change happening. And since it's a product, it doesn't affect. Another easy method to observe that beta of xy is equal to beta of yx is to put 1 minus t equal to theta. Then your t will become 1 minus theta. So there is just an exchange between these two. That's how they are the same. Now you can also observe that if x and y are both positive integers, then beta of x comma y is nothing but x minus 1 factorial into y minus 1 factorial divided by x plus y minus 1 factorial. To see this, let us see a simple case. When x is equal to 6 and y equal to 4, both are positive integers. So what is beta of 6 comma 4? It is integral 0 to 1 t power 6 minus 1 into 1 minus t power 4 minus 1 dt. Now if you apply integration by parts, it becomes t power 5 into integral of this is 1 minus t power 4 divided by minus 4 evaluated from 0 to 1 minus integral of 0 to 1 derivative of t power 5 is 5 into t power 4 into 1 minus t power 4 divided by minus 4 dt. This minus and minus will become plus, and when you put t equal to 1, this 1 minus 1 will become 0. When t equal to 0, the first term will become 0. So both this term completely vanishes, and what remains is 5 by 4 plus 5 by 4 into beta. This is t power 5 minus 1 into 1 minus t power 5 minus 1. So beta 5 comma 5. What you can say is beta of 6 comma 4 is equal to 5 by 4 into beta of 5 comma 5. Or in general, you can observe that beta of m comma n is equal to this 6 becomes 5, that is m becomes m minus 1 divided by this denominator is 4 itself. So divided by n into beta of 5 comma 5. The 6 has become 6 minus 1 and 4 has become 4 plus 1. So beta of n minus 1 comma n plus 1. Okay. So if you continue this, you can write it as this divided by m minus 1 by n into this. You can observe that it is m minus 2 divided by n plus 1 will appear as it is n plus 1 into beta of n minus 2 comma this n plus 1 will get increased by 1. So n plus 1 will be increased by 1, so n plus 2. So you can see that this 5 beta of 5 by 5 will become 4 by 5 into beta of 4 comma 6. So ultimately it is 5 by 4 into 4 by 5 into beta of 4 comma 6. Again this beta of 4 comma 6 will become 3 by 6 into beta of 3 comma 7. So it is 5 by 4 into 4 by 5 into 3 by 6 into continuing like this. You get 2 by 7 into 1 by 8 into beta of 1 comma 9. Now this beta of 1 comma 9, that is same as beta of 9 comma 1. That is integral 0 to 1 t power. I'll take beta as x as 9 and y as 1. So t power 8 into 1 minus t power 0 dt. So that's equal to this will go, this will become 1, and what remains is t power 9 divided by 9 evaluated from 0 to 1. So it is 1 by 9. So this beta of 1 comma 9, we can write it as 1 by 9. So altogether it becomes 5 into 4 into 3 into 2 into 1. That is 5 factorial divided by, and this is what 4 into 3 into 5 into 6 into 7 into 8 into 9. That is 9 factorial, but 1 into 2 into 3 are missing, right? So it is, you can put that 3 factorial here. So beta mn is going to be m comma n is nothing but m minus 1 factorial into n minus 1 factorial divided by this 9 is actually 6 plus 4 minus 1. So it is m plus n minus 1 factorial. So when x and y are positive integers, you can see that beta of x comma y is equal to x minus 1 factorial into y minus 1 factorial divided by x plus y minus 1 factorial. Thus when x and y are integers, positive integers, you can easily calculate beta of xy because you know the value of factorials. We have already seen the relation that beta of x comma is equal to 2 times integral 0 to pi by 2 sin theta power 2 minus 1 into cos theta power 2 y minus 1 d theta by putting t equal to sin square theta. Okay, now if you take this particular value, that is power as 2x minus 1 as a, and this 2y minus 1 as b, then you can write x is equal to a plus 1 divided by 2 by bringing this 1 to this side, and y equal to b plus 1 divided by 2. So here in place of x and y, you will get a plus 1 divided by 2 and b plus 1 divided by 2, and this 2 can be brought to the left side. So you can say that integral 0 to pi by 2 sin theta raised to a cos theta raised to b d theta is equal to 1 by 2 times beta a plus 1 divided by 2 or b plus 1 divided by 2. Now suppose that a and b are odd integers, positive odd integers, then what happens is this becomes a this a plus 1 divided by 2 is always a positive integer, and b plus 1 divided by 2 is also a positive integer. In that case, beta value can be easily found, right? Whenever this a and b are odd integers, you can apply the formula, that is integral 0 to pi by 2 sin theta raised to an odd number into cos theta raised to an odd number d theta is equal to half into beta of sum m comma n, where m and n are positive integers, and they can be found using factorial notation. For example, integral 0 to pi by 2 sin theta raised to 7 cos theta raised to 5 d theta is equal to 1 by 2 into beta of 7 plus 1 by 2, 5 plus 1 by 2, that is beta of 4 comma 3. Now what is beta of 4 comma 3? It is 1, okay. 1 by 2 is already there. 4 minus 1 factorial, that is 3 factorial into 3 minus 1 factorial is 2 factorial divided by 4 plus 3, 7 minus 1 factorial is 6 factorial. So when you calculate this, you can easily find that it is 1 by 120. So such integrals, whose sine theta, cos theta powers are odd numbers, can be told in terms of beta function. Now we try to establish a connection between gamma function and beta function. Gamma function, as you remember, it is gamma of x is equal to integral e power x minus 1 into e raised to minus t dt, integral from 0 to infinity. So these two functions are related by this formula. Beta of x comma y is equal to gamma of x into gamma of y divided by gamma of x plus y. And this is actually motivated from this particular relation. Beta of m comma n is equal to m minus 1 factorial into y n minus 1 factorial divided by m plus n minus 1 factorial. We already know that there is a connection between factorial notation and gamma notation, right? Because m minus 1 factorial is gamma n and n minus 1 factorial is gamma n, and x this m plus n minus 1 factorial is gamma of n plus n. So generalizing that, you can see that beta of x comma y is equal to gamma x gamma y divided by gamma of x plus y. This is valid for all positive values x. For integers, this becomes factorial notation. And using this relation, you can easily see that the gamma of half is equal to root of pi. This is because you take x is equal to half and y equal to half in beta x y. So what you get is beta of half comma half is equal to gamma half into gamma half divided by gamma of 1. Numerator is gamma half square. So gamma half square is equal to gamma 1 is 1. So 1 into beta 1 by 2 comma 1 by 2, that's equal to 2 times integral 0 to pi by 2 sine theta raised to 0 cos theta raised to 0. So that is 1 d theta. If you integrate it, so you can say that gamma half square is pi, and therefore gamma half is equal to root pi. Thank you.